morning to you all. This flow measurement topic, it is the last topic in the unit number 3. In flow meter, first topic is rotometer. So this some of the other flow measurement instruments already we studied in fluid mechanics and FMHM lab. And whatever the topics left in rotometer or flow measurement, so we are going to discuss in the syllabus or this particular topic. First of all, the rotometer, it is a device to measure the volumetric flow of the fluid in a closed tube. So this kind of flow measurement, it is required at many real-time application. For example, keeping this flow meter with the water storage dams is essential. Then only they can control the water flow. Otherwise, what happens? It will be like if you are not controlling the flow or not measuring the flow of the fluid or water, then it will be either short of water to one place and another place it will be with the flood. So the precise controlling is required for the flow rate of water or any fluid. So this is the real-time application. With this real-time application, so I am going to proceed further. So first of all, the rotometer, it is a volumetric flow device and it belongs to class of meter what is called variable area meters, which measure the flow rate by allowing cross-sectional area of the fluid travel through vary and causing a measurable effect. This is the working. I am going to show two different images to get better understanding. So here we are using a float. So initially it is a equilibrium position. Here we have a tapered metering tube is there. Inside the tube we are keeping the float. So the float, it will move up to this. So whenever the water flow it is coming this direction, then the based on the volume of fluid or fluid flow, this float it will rise. If the water comes with the higher flow rate, the float it will reach us at the maximum height. So if flow rate is less, what happened? Flow rate is less, then it will be at a somewhat moderate position. Suppose the water there is no flow or very little flow is there, then float it will be at zero position. So this is the working of the flow meters, what is called rotometer. So rotometer, it's another diagram, it is available. This is a real-time application. You have a tapered tube. Here you have a float. Based on the based on the flow of fluid, the float it will be positioned. So based on the float position, we can going to measure the flow rate. So this kind of things you can. We have a practical example to understand this rotometer. I think the bunk shops we are drinking a goli soda. Goli soda means there is a glass ball. It will be inside the bottle. So there, what happened? The similar principle. So whenever you are raising, then what happened? The float, this will come and locked. So this is the goli soda is a real-time example to understand this. So next I move to principle and working. So principle and working already we discussed. Here they are discussing the volumetric flow. A higher volumetric flow rate given the area increase the flow speed and drag force so that float will be pushed upwards. However, as the inside of rotometer cone shaped, it is widened. So area around the float through which the medium flow increases. The flow speed drag force decrease until there is a mechanical equilibrium of float weight. So here again I am going to correlate with the diagram. Here the water is coming with higher flow rate. The float is pushed up to the maximum height. So that indicates the maximum distance moved by the float indicates the higher flow rate. Suppose water flow rate is less, then what happened? The float it will be at a very lower position. So that indicates the flow. Now I come to the application of the advantage of rotometer. It is very simple in operation, easy of reading and installation, and relatively low cost because you are using one conical tube and float. That is the requirement. Then on measuring scale. So these are all the components for rotometer. So therefore the relatively low cost. They handles wide variety of corrosive fluid. You can use wide variety of corrosive fluids. Even you can acids or some other chemical fluid. So that can be handled or that flow rate can be measured. easily equipped with the data transmission indicating and recording device. Even you can put the recording device also. Then disadvantages: glass tube subject to breakage. That glass tube, it will not get longer time. Then limited to small size pipes and capacities, is not suitable for larger pipes. Then less accurate compared to venture and orifice meter. The venture meter, orifice meter, already we discussed in fluid mechanics and FMHM laboratory. So that when compared to venture meter and orifice meter, this is accuracy is little bit less. Then one more bigger limitation of this flow meter, this can be mounted only vertically, not in horizontal position. Suppose water flow, it is in horizontal position, so this float, it will not work. So this flow meter, you can see the animation video by clicking this link. You can check with the animation video also. So next topic available in flow meter is turbine flow meter. The turbine flow meter, first I want to show explain the complete diagram. So here you have this is the turbine flow meter. So here inside we have a turbine, right? So this is your the fluid passage. It's like a cylindrical tube. Here we are keeping our turbine wheel here. So turbine wheel, you look at this, it's having number of blades. So one of the blade, it is carrying the magnet. So just opposite to here, you have a permanent magnet. Permanent magnet is placed. So here we are keeping magnet pickup coil. So this is called frequency or counter, how many times it is moving. So this is housing of meter. So in this illustration, the water or whatever fluid, it will flow through this direction. So that what happened, the fluid flow which which rotates the turbine meter. So based on the water flow, the RPM of the revolution of the turbine, it will be more. If water or any fluid comes with very high speed, then the rotation of turbine, it will be very less. So based on the rotation here, magnetic pickup coil is there. Directly it will generate EMF and it will get the count. So based on the count, how fast it is rotating. If it is rotating fast, flow rate is higher. If flow rate is lesser, the turbine will rotate very slow speed. So here just counter. Here we are using as a counter. The permanent magnet, now I come for description. The permanent magnet attached to the body of the rotor is polarized 90 degree to the axis of rotation. So axis of rotation, the flow direction, we are keeping 90 degree. When the rotor rotates due to velocity of the fluid, the permanent magnet also rotate along with it. Whenever turbine rotates, magnet also rotate. Therefore, rotating magnetic field will generate magnetic pulse in the pickup coil available here, magnetic pickup coil. Due to this AC voltage, the generated whose frequency is directly proportional to flow rate. Faster, higher flow rate, turbine will rotate faster, so that here more number of pickup will be there. So that indicates the fluid is flowing with very high speed. So this is the principal diagram. Here this is the original diagram. So normally the turbine blade, it will be arranged like this. So here they are putting the magnetic pickup coil. So water flow, it will be in this direction. Then based on the count, based on the speed of turbine rotation, the fluid flow is assessed. Again, come to the advantage of this. When compared to rotometer, this is having good accuracy and repeatability, and this is easy to install and easy to maintenance. There is no mechanical elements or linkages. So here low pressure drop is there. Electric output is available. So even count, you can put it either count or you can keep it as a EMF. Then good transient response. So this is the another important thing. Then the limitation is when compared to previously discussed flow meters, this is high cost because we are giving turbine, we are giving magnet, putting magnetic pickup coil. Then another setup for to count the flow speed. The bearing of rotor may subject to corrosion. So that is another problem. Then wear and tear problem is there. So wear and tear problem, the turbine, the kinetic energy of the fluid directly, it is acted on the turbine fluid. So therefore wear and tear, it is unavoidable. Coming to the application, it is used to determine the fluid flow in the pipes and tubes. So flow of water and river. So even you can keep it smaller water tank. They can keep this setup and we can measure the water. And used to determine the wind velocity in weather situations or condition. Even not only the fluid, even air also one kind of fluid. Even you can measure the velocity of the weather or velocity of the wind also. So next one we are going to see the electromagnetic flow meter. Here this is totally functioning the Faraday's law of electromagnetic induction. So here you know Faraday's law. So one is which shows the this finger shows the velocity of rotation. Another one, this finger, down finger, that means in index finger, this thumb shows velocity, index finger shows magnetic flux density, and another finger which shows induced voltage. You look at this, all the three fingers are mutually perpendicular or perpendicular to each other. So this is the electromagnetic law. So here how we are measuring means here you have a velocity of the fluid is there. So previously velocity of the conductor, now velocity of the fluid, it will induce the magnetic flux and it induce the voltage. So here what happened from this principle, the voltage induced across the conductor as it moves at right angle through the magnetic field is proportional to the velocity of the conductor. So here what happened, we can use the conductive fluid in this direction, so that you have a magnetic field, available in this direction. Magnetic field is available in this direction. Then we are allowing conductor. So whenever a magnetic field you are moving the conductor, EMF will be generated. So here the generated EMF is directly proportional to the velocity of the fluid. So velocity of the fluid directly proportional to induced EMF. So just probing the induced EMF, you can able to assess the velocity of the fluid. So here the description already we did. The magnetic field is applied to meter tube, which result potential difference which is proportional to the flow velocity perpendicular to the physical line. The physical principle at work is electromagnetic induction. The magnetic flow meter requires a conducting fluid, that is important. So non-conductive fluids we cannot use. And again I will come back. This is the working principle diagram. So here is electromagnetic law, Faraday's law. You keep three fingers mutually perpendicular to each other. So this is your direction of fluid flow, and this indicates the magnetic flux direction. We are keeping a magnetic field. In a magnetic field, if you are allowing a conductor with a certain velocity, the EMF is induced. So based on the velocity of the fluid, EMF will be generated. By probing the induced EMF, we can assess the velocity of the fluid. So animation video for this, or if you want to see any video related to this electromagnetic flow meter, you can watch. Now I come to the advantage. It is a handle greasy material. It can be handled greasy material. But however, the material should be a conductive one. It can handle corrosive fluid also, and accuracy is good. It is having very low pressure drop. These are all the advantages, and the limitation is cost is more. It's like a dynamo setup, so cost is relatively less, and heavy and larger in sizes. So that is our limitations. Heavy and larger size. The explosion proof when it is installed in hazardous electrical areas. So some explosion proof is required. Otherwise, the setup it will be exploded. Then it must be full at all time. It is important. Then applications, you can measure the flow of corrosive acids, cement slurries, paper pulp, detergent. So these are all the fluids you can use. But important thing is all the working fluid, it should be a conductor. Non-conductive fluid you cannot measure by using this method. Next, we are going to discuss the measuring principle of ultrasonic flow meter. So ultrasonic flow meter, already the level measurement we have seen similar kind of ultrasonic measurement setup. So here there is a pipe. Both side of the pipe you have a transducer with a receiver. Receiver, what is called ultrasonic transducer and receiver. So this is called T1, this is called T2. Suppose if your water is flowing like this, then we are giving the ultrasonic wave and allowing to move. So here what happened, ultrasonic wave, it reaches at the bottom, then again returned back. So the return back, we have a receiver to receive the ultrasonic wave, and we will receive. So based on the flow, then flow rate, then the time it will reach here and coming back. So here they are clearly discussed. The ultrasonic signal is transmitted toward the upstream side against the flow direction. The more propagation time is required. So here what happened? Transmitted to the towards the downside with the flow direction. Flow direction, the propagation time is less. Sorry, more propagation time is required. Flow against the flow direction. Then what happened? On the other hand, transmitted downstream side along the flow direction, the propagation time is less. So therefore, the difference in time between T1 and T2 proportional to the flow velocity. So this timing, it will be in microseconds. From this value, we can assess the flow of the fluid. Again, coming to the advantage, the ultrasonic flow meter, it is high accuracy because we are using ultrasonic wave approved and custody transfer, high turn down, and to measure low and high pressure fluid, and we will get good repeatability of reading or measurement. Can clamp on pipe with no penetration, so you need not make any hole on the pipes. Then tolerate extreme temperature also, even high temperature also. This will work because we are using ultrasonic wave as a working fluid. So this more reliable when compared to other mechanical related flow meters. Here there is no moving parts, hence what happened, the wear and tear and the maintenance cost, it will be less. The limitation is this required high initial cost, depth and fluid impact performance and measurements accuracy. Then noise, it's a problem. So noise generation, it is one of the bigger limitation in this system. Then pipe walls can interface with ultrasonic signal, clamp on meter. Then again, build up on inside pipe walls can reduce inside diameter of the pipe, which affect the measurement accuracy. So these are all the various limitations of the ultrasonic flow meter. Then we have another one is hot wire anemometer. So here, so far we have discussed, so all are in fluid form. Here it will be in liquid state. So here this particular hot wire anemometer, it is used to measure the gas flow rate, speed of the gas. When electrically heated wire, here the principal diagram, it is very clearly here. You have two conducting wire. So here we are giving electrical load. Here when electrically heated wire, we are giving electrical signal and we are heating the wires. Electrically heated wire is placed in the flow gas stream. So we are supplying your gas in this direction. The heat is transferred from the wire to gas, hence the temperature of the wire reduces. And due to this, the resistance of the wire also changes. So this change in resistance of the wire becomes the measuring the flow rate. So already we said here we are going to measure the flow rate based on the variation in the resistance value. So thermocouple gauge, we have seen the similar thing. So now here again I will come back hot wire anemometer. Here by using electrical circuit, we need to heat the wire. Now we are supplying the fluid, whatever flow of the fluid you want to measure, you just supply through it. So because of the fluid flow, the coil heating wires, it will lose its temperature. That means here they are talking in terms of resistance. So therefore, this change in resistance of the wire become the measure of flow rate. So we have a constant current method, constant current method and constant temperature method. Two methods are there. So here constant current method, we are supplying the gas flow through this based on the variation in resistance, temperature reduction, then resistance variation. We are going to measure the flow rate. So here what happened, the principal method is to maintain the temperature and resistance of the sensing wire at constant level. Here what happened, they are measuring the flow rate, the electrical current required to bring back the resistance, and hence the temperature, corresponding temperature of the wire, it is taken as a measure of fluid flow. So this is the another circuit diagram to measure the constant temperature method for measuring flow. Then next one is probably last topic of this particular unit is a laser Doppler anemometer. So laser Doppler anemometer, it's a laser Doppler velocimetry or laser Doppler anemometry. You please listen carefully. The question may be asked in both ways. Suppose sometimes it's a laser Doppler velocimetry. Here we are measuring velocity of the fluid. Sometimes it may be called like that. Yeah, this is topic is flow measurement. In the flow, they are measuring the velocity component. So students, you cannot confuse with this word velocimetry. So this method is measured by using Doppler shift in the laser beam. So here we are using laser beam. So based on the fluid flow, the Doppler shift it will come. Based on the Doppler shift, we are going to measure the fluid flow. So here we need to use the laser beam to measure the velocity in transparent or semi-transparent fluid. Completely non-transparent fluid we cannot measure. That is a limitation of this. So through that completely partial transparent fluid, then what happened? The light it should flow through the fluid. That is important. So here already we discussed when particles in great motion they produce a Doppler shift. So here laser Doppler anemometer use the beam of light from laser which is divided into two beam by using beam splitter. A particulates flowing along the air molecules near and where the beam exits and reflector, what is called backscatter. When the particles are in great motion, they produce a Doppler shift for measuring wind speed in the laser light, which is used to calculate the speed of the particle and therefore air around the anemometer. So this is the principal diagram for a laser Doppler anemometer. Here we are using a laser source. Then laser source is divided into a two rays by using beam splitter. Then the laser which comes out from the beam splitter is focused through the lens through the fluid. So that here transparent fluid, if fluid is transparent, there is no problem. The laser rays is passed through the pipes. So here we are putting the particles. We are putting the particle for measurement. So here what happened? The scattered light it will become finally here what happened? Light detector it will be uh, detecting the what happened? Refracted light beams. Right here, what happened? The light detector. We are going to we have a Doppler shift. So based on the shift of the Doppler or the dimension of the shift, we are going to measure the flow rate. So here you can look at this. The shift is proportional to the velocity of the particle. There is essentially zero disturbance of flow by the laser. Here the advantages for LDI is no disturbance of flow, one is, and another one high spatial resolution of the fluid flow, the velocity data that are independent of the fluid thermodynamic particle, an output voltage that is linear with velocity, so no need for any calibration. So disadvantages are both the apparatus and fluid must be transparent. That is a important limitation. If fluid is non-transparent one, then we will get the obstruction. We will get the obstruction in light flow. So again, for the better understanding, I added one more image to understand. So here, this display, we are going to measure the Doppler shift. So based on the Doppler shift, we are going to measure the fluid. The application, you can measure the fluid with laminar and turbulent flow. Then some investigation on aerodynamics. So this is it is used. Then the fluid with the supersonic flows also you can measure. Even turbines, automotive. So this kind of applications we can use this kind of flow meter. Then liquid flow, all kind of liquid flow, provided it should be a transparent one. The non-transparent fluid we cannot use this. The surface velocity and the vibration measurement also we can use this. Then here even you can use the hot environment. If temperature goes to a little bit up from the room temperature, even you can measure. So here what happened? Velocity of the particles also you can do. You can measure it. And many other applications you can use. So if you want expecting further information, you can look at the links. Thank you.